The steps in creating custom subnet masks. Step 3. Determining the subnet IDs. There are essentially 4 steps to custom subnetting. The first step is to design the physical network. Now, in many cases, the physical network may be already designed for us, and what we need to do is determine, first, the number of physical segments on the network. Then second, we have to figure out the maximum number of hosts on each physical segment. Now, step 2 is to choose a subnet mask, actually a custom subnet mask, that creates a number of subnet IDs that is greater than or equal to the number of physical segments, and also the subnet mask, the custom subnet mask, must give us a number of host IDs on each physical segment that is greater than or equal to the actual number of hosts on each physical segment, because we always have to match the software, that is the numbering of the IP addresses, to the physical segments. Then, step 3, we have to determine and number our subnet IDs, because they will be used when we sit down and number the actual host addresses. To properly address our IP networks, we'll need to create a separate subnet or range of IP addresses for each physical segment. Now, we will specify these different subnets or range of IP addresses with a subnet ID. Now, I'm starting with a Class B address, the 152.77.00. Now, the default subnet mask, of course, because it's Class B, is 255.255.00. The 255 is indicating the portion of the IP address that is the network ID, and the 0 is indicating the portion of the accompanying IP address that is the host ID. Now, according to this Class B network and the associated subnet mask, I have one network ID, and I could support 2 octets of hosts, which is about 65,000 hosts. But what I want to do is create subnet IDs to number my physical segments. So what I'm going to do is, in a sense, steal or take some of the bits normally reserved for host addresses and turn them into subnet IDs, or use them as part of my subnet mask. When using custom subnet mask, we set up our subnet IDs like this. Now, all hosts or device will share the same network ID. Now, in our example, our network ID is 152.77. Now, all physical segments, all hosts will start with that because that's assigned to our entire network. Now then, each physical segment of the network would have a unique subnet ID, and then all computers on that physical segment would share that same subnet ID. Now then, of course, each host would have to have a unique host address, and that's unique to the subnet ID. In the next few presentations, we'll be going through an example to demonstrate how to do custom subnetting. Now, in this example, we have a physical network, and that physical network has 5 physical segments, and those segments need to support a maximum of 5,000 hosts on each segment. We've had assigned to us a Class B address, 152.77.0.0. Now, that's our network address, and it's our job as administrators then to set up the IP addressing for our network. This is the chart we've developed. This is the subnet ID host chart for Class B network, and it specifies all the valid subnet masks we can use with a Class B network subnetting 1 octet, ranging from 1 bit to 8 bits, and it gives us the number of subnet IDs and the number of hosts per subnet ID. And then whenever confronted with a design problem, first we identify how many physical segments we have, how many hosts per physical segment, and then we look for a subnet mask, a custom subnet mask that gives us enough subnet IDs and gives us enough host IDs per subnet to match the physical network. So we've looked at all our possible choices for custom subnet masks, and we found one that works. Now, we found that the custom subnet mask of 255.255.224 works for our network. Now, the first 2 octets, remember we're using a Class B, they're cast in stone, so it'll always be 255.255 and then some number which is the custom subnet mask, in this case 224, because 224 gives us 6 possible subnet IDs, and we have 5 physical segments, so that works, and it also gives us over 8,000 host IDs per subnet, and since we only have 5,000 physical host per physical segment will have plenty of addresses. So the subnet mask 255.255.224.0 would be used on all devices on our network. And then it'd be our job as administrator to hand out the actual IP addresses and potentially default gateways. In step 1, we designed or assessed the physical network, and we determined the number of physical segments and the number of hosts on each physical segment. In step 2, we then chose a custom subnet mask that provided us with a number of subnet IDs that was greater than or equal to the number of physical segments, and also allowed us sufficient host IDs for each physical segment. Now in step 3, what we're going to do is we're going to actually number or determine the subnet IDs. Now remember, a subnet ID is a range of IP addresses that we will assign to the hosts on the same physical segment. And the way the numbering works is that, now again, all computers or all hosts on our network will share the same network ID. Each physical segment will have a subnet ID, and all the hosts on that physical segment will share not only the network ID but also the subnet ID, and then each host will have a unique host ID. Now each physical segment will have a unique subnet ID, and the range of IP addresses in each subnet will be determined by the subnet mask. And it's an important point to make that we just can't use any IP addresses when we set up our networks. When we do custom subnetting, we must meticulously number the networks in order for network communication to be successful. In our example, we have a physical network in which there are 5 physical segments and 5,000 hosts on each physical segment. We've also been assigned a Class B address, the 152.77.0.0, and we've chosen a custom subnet mask. Now the custom subnet mask we've chosen is 255.255.224.0. Now this subnet mask would be used by all devices on our network, and we've chosen that subnet mask because the subnet mask at 224 gives us a possibility of 6 subnet IDs and supports up to 8,190 host IDs per subnet ID. And that's adequate for our physical network, because we always have to remember that we have to have enough subnet IDs and enough host IDs to support the physical network. When viewing the subnet mask, we take a look at the first 2 octets, the 255.255. Now these are cast in stone, and there's nothing we can do to change that. But really what we want to do is focus on the subnet ID portion of the subnet mask, the 3 bits, the first 3 bits in the second octet. Now remember, these 3 bits will be available to create these things called subnet IDs. Now it's important to take a look at our subnet ID and notice that it only is 3 bits of an octet. Now, when we convert this to decimal numbers, we'll be converting the entire octet, which has numbers both for the subnet ID and the host ID. And that's where the decimal numbering becomes a bit confusing, but as long as we stay with our binary view of things, it should be easy to figure out. We've decided on a subnet mask of 255.255.224.0. Now remember, since this is a Class B address, the 255.255 is cast in stone, and we're setting up our custom subnet mask of 224. Now the custom subnet mask of 224 says that the first 3 bits of that octet are part of the subnet ID, and the last 5 bits are part of the host ID. Now let's take a look at the possible subnet IDs from a binary perspective. Now I've listed those out on the chart on the left. Now the first possible subnet ID, now again I have 3 bits, these are highlighted in red, dedicated to the subnet ID. The first one would be 000 in red. Now that's invalid, just like 111 will be invalid at the end, because we have to throw out the high and the low, unless of course all our devices support RFC 1812, and then we don't have to throw these out, but for the purposes of these courses, we will throw out the first and the last. Now the first actual subnet ID we could use in binary would be 001. Second subnet ID in binary, again focusing in on the subnet ID, the red portion, would be 010, then to 011, and all the way down to 111, throwing out 111. When we convert these numbers to the decimal numbers, we have to convert the entire octet, not just the subnet ID portion of that octet. So when we take that third octet and we convert it, now in the case of the first subnet ID, we convert the octet 001, that's the subnet ID portion, but then we have to add the host ID portion, 5 additional zeros, to convert the entire octet to 32. So our first subnet ID would be 152.77.32.0. And then doing the decimal conversions right down the line, the next one is 152.77.64.0, 96.0, all the way to 224.0. There is a short way to determine the subnet IDs for any custom subnet mask. Now again, in this situation, we're going to use the subnet mask of 255.255.224.0. We're going to focus in on the subnet ID portion, or the custom portion of the subnet mask, the 2240. Now when we convert that to binary, of course, that octet becomes 3 ones and 5 zeros. The way to determine the subnet ID is to look at the decimal conversion value of the farthest right 1 bit. Now in this case, the farthest right 1 bit is the third bit. Now remember from binary math that the farthest left bit, the decimal conversion factor is 128, the next bit it's 64, the next bit it's 32. So our first subnet ID would be 32, or in this case 152.77.32.0. Then every subnet ID starts at a value or a multiple equal to the first subnet ID. So in our situation, the first subnet ID started at 32. Each subnet ID after that will start as a multiple of 32. So the next one is 64, next one is 32 added to that, 96, and on and on. Let's perform that same calculation with a subnet mask of 240. Again, we look for the decimal conversion value of the farthest 1 bit of the custom subnet mask. In this case, that value is 16. Again, from a binary math perspective, the farthest left bit is 128, next one is 64, 32, the fourth bit, the farthest one to the right in our situation, the decimal conversion value is 16. So the first subnet ID would be 152.77.16.0, and then every subnet ID after that would increment equal to 16. So the next one would be 32, 48, 64, and on and on. Here's a chart where we've taken all the different custom subnet masks, and then we've listed out the subnet IDs associated with each custom subnet mask. And in each situation, what we've done to determine the subnet ID is to look at the farthest 1 bit in the subnet ID and convert that to its decimal equivalent. And we can see that the first subnet ID, now when we have a single bit dedicated to the subnet ID, the first subnet ID is 128. And then you can see that the numbers actually half. So the first subnet ID is 128, next one is 64, and they half all the way to 1. Now remember, if the first subnet ID starts at, for instance, 64, each successive subnet ID will also start at 64. Or if the first subnet ID starts at 8, each successive subnet ID will start at 8. Let's take a look at a couple other examples on how to determine subnet IDs. Now we have the first IP address of 152.77.0.0. Now this is a Class B address, so the subnet mask will always start at 255.255, and then the custom subnet mask will be in the third octet. Now this is 248. Now if we look up on the table, 248 says that the first subnet ID would start at 8, so it would be 152.77.8.0, and then each subnet ID would increment a multiple of 8. Next one, 1624. Now in the next scenario, again we're using the IP address 152.77.0.0. It's a Class B address, so all computers on my network would start with 152.77, and then I would subnet in the third octet. Now in this case I'm using a subnet mask of 255.255.2550. It's essentially using a C subnet mask on a B network. Well, looking at the chart, the custom subnet mask of 255 says that the first network ID would start at 1, and each network ID would then start as an increment of 1. So my first subnet ID would be 152.77.1.0, next one 152.77.2.0, and on and on. Now my last example here, I'm using a Class A address, 33.0.0.0. Now with a Class A address, only the first octet is cast in zone 255, and then I subnet on the second octet. Now in this case I've used a custom subnet mask of 240. Now according to the chart, the custom subnet ID, the first one we're going to use is 16. So my first subnet ID would be 33.16.0.0. And then every subnet ID would then increment 16. So the next one is 33.32.0.0, and on and on. In our example, we used a custom subnet mask of 255.255.224.0. Now that gave us 6 possible subnet IDs, and what we're going to do is use those to set up our numbering on our physical segments. So our first physical segment would have the subnet ID of 152.77.32.0. Next one 152.77.64.0, 96.0, 128.0, and 160.0. Now remember, we did not use the first subnet ID, the 0 subnet ID, or the last one, which is 224. Now we could use those if all of our devices were RFC 1812 compliant, but in this case we're going to throw those out. Now we only used 5 of the possible 6 subnet IDs, so we would have another subnet ID, the 192 subnet, for expansion at later times. Now the reason we've created these subnet IDs is because these give us the boundaries or range of IP addresses that are assigned to the devices on each physical segment, and we'll need that in the next section when we start actually numbering the host IDs. Here we've taken 2 different charts and added them together. We started out with our subnet ID host chart for a Class B network, where we've listed the different custom subnet masks, and then also listed the number of subnet IDs and the number of hosts per subnet ID that each custom subnet mask would give us. And then we've added the subnet ID information, listing out where the first subnet ID for each custom subnet mask starts, and also the increment of each successive subnet ID. With this completed chart, you could take any network design problem and determine the correct custom subnet mask, and also determine the subnet IDs that would be needed for each physical segment.